Okay, let's talk about calcium homeostasis for a second. So why is calcium so important? What does it do for us? Well, first of all, you have to have it for muscle contraction. And that's all muscle contraction. Smooth muscle, skeletal muscle, cardiac muscle. Without calcium, you can't have any of those. Blood clotting, which we'll talk about that when we get to blood. Synaptic transmission. So in your nerves or neurons, you have to have calcium in order for the vesicles to migrate to the plasma membrane and exocytose its neurotransmitter into the synaptic cleft in order to have a transmission of an action potential. It's important in insulin production, which we'll talk about that shortly. Pretty important. If you have hypocalcemia, you have decreased nervous system reactivity. If you have hypercalcemia, you have increased nervous system reactivity, and not in a good way. So calcium is really, really important for us. So where is it? Where do we have calcium in our body? Well, we have it in the intracellular fluid. I have to put ICF. And that's about 1% is located in the inside the cell, so an intracellular fluid. In the extracellular fluid, we have about 0.1%. So the rest of our calcium is in the bone. So bones are definitely affected by calcium homeostasis and by the hormones that regulate it. So we have certain cells in the bone. We have osteoblasts. We know those that builds bone. So in building bone, calcium is pulled from the blood. So when we're building bone, calcium is pulled from the blood and deposited into the bone. That's what makes bone hard. Osteoclasts, on the other hand, break down bone. And when that happens, then that calcium is dumped into the blood. Which is needed for all of these things up here. Okay? So how do we regulate that? Who watches out for that? Well, we have these little glands called parathyroid glands. So parathyroid glands are located on the back of the thyroid gland. There are 4 little nodules on the back of the thyroid gland. and they monitor calcium levels in the blood. Monitor blood calcium levels. And they are looking for low blood calcium. That's all they're looking for, is to make sure we don't have low blood calcium, because we have to make sure to be able to do these things over here. So if we have our little parathyroid cell here, and here's my little receptor. So when blood calcium is low and blood goes through there, when the parathyroid, because remember we're in the gland now, so the gland is the integrator, and when it sees low blood calcium, it will secrete PTH into the blood. PTH. PTH will target a couple of things. So the PTH will target, first of all, this stupid looking bone, but bone tissue. So it will target bone to increase osteoclast and increase their activity to dump calcium into the blood. It also has an effect on the kidney. So it tells the kidney, so PTH targets the kidney to reabsorb calcium. Don't let it go out into the urine. Reabsorb it into the body. PTH also has an effect on vitamin D, also called calcitriol. And vitamin D allows for or targets, should I say, because vitamin D is kind of like a hormone. It's not really as much like a vitamin. It's lipid soluble. It acts more like a hormone. So it targets the digestive tract to increase absorption of calcium. So PTH has an effect on all of these things. Again, targets the bone to break down bone to put that calcium into the blood, targets the kidneys to tell the kidneys to reabsorb calcium, and also to increase vitamin D and get vitamin D to target the digestive tract to increase absorption of calcium from what you're eating. All right, the last thing on calcium homeostasis is calcitonin. Let's do this in a different color. So calcitonin is a hormone that comes from the thyroid gland, not the parathyroid. And it basically stimulates osteoblasts. So it increases osteoblast function. So it basically, Calcitonin will increase when blood calcium levels are up. So an increase of blood calcium level will cause the secretion of calcitonin. And calcitonin will target the bone, target osteoblasts to make bone, and then take calcium from the blood and deposit it into that bone that is being made.